Genetic antennas are also known as evolved antennas, and they often resemble paper clips bent in different ways and connected to a radio frequency connector. Unlike usual antennas, which are most often designed by humans, nowadays with the help of computer modeling as well, genetic antennas are designed by automatic computer design using an evolutionary algorithm that mimics Darwinian evolution. These algorithms have been called genetic algorithms. Studies on genetic antennas have been published as early as 1990s. It was considered for mission critical applications which involved stringent, conflicting or unusual design requirements like unusual radiation patterns, for which none of the existing antenna types were adequate. A 2014 paper described two novel antenna systems for tri-band GNSS applications. GNSS stands for Global Navigation Satellite System and refers to any satellite constellation that provides global positioning, navigation, and timing services. Some of the examples of GNSS are Galileo by the European Union and GPS by the United States of America. Indian Regional Navigation Satellite System IRNSS, also known as NAV-IC, Navigation with Indian Constellation, provides similar but regional coverage. Going through the process of design, it looks very much like genetic evolution. Computer program starts with simple antenna shapes and then adds or modifies elements in a semi-random manner to create several candidate antenna shapes. These different options are evaluated to find out how well they fulfill the design requirements, and a numerical score is computed for each pattern. After that, similar to the Darwinian natural selection, portion of the antenna with worse scores are discarded and those with highest scores are retained. The process is repeated, and using operators similar to mutation and crossover of chromosomes, antennas with higher scores are designed. After a number of such steps, populations of antennas are evaluated and highest scoring design chosen. The final result is often better than the best manual designs and has a complicated asymmetric shape which could not have been found with traditional design methods. The antenna shown in the illustration was evolved to have a combination of wide beamwidth for a circularly polarized wave and wide impedance bandwidth to cover the up and downlink frequencies at X band for a 2006 NASA mission called Space Technology 5 STS-5